recording. Okay. Good. So class has begun. Everybody, please remember, especially those of you that just barely logged on, the way I take roll is for you to type something into the chat box. So preferably hi, hello, or something to that effect. If you don't type that into the text, into the chat box, you will not get credit for attending. And if you read the disclosure statement, then you know that attendance is 20% of your grade, which is not something I normally do in this class, but we're going to do it now in order to make sure everybody attends these sessions. Good, I see it. So I see a lot of people typing into the chat box. Glad to see that. All right. So speaking of the disclosure statement, your first assignment was to download the disclosure statement and confirm that you had read it, and then your parent needed to confirm that they had read it. And so I looked on Canvas earlier today, and I saw that most of you have done that, but a few of you have not. So Elliot, I see you got your camera on, which is perfectly okay. Is that Milo that I just saw there? Yeah, good. Yeah,
I'm turning it off right now, yeah.
Okay, fine. Just because I'm recording, that's why.
No,
And
yeah,
by the
yeah.
way, was that Milo that I just saw an arm there?
I think.
Okay.
Maybe.
All right, kick him in the pants and say, hey, this is from Mr. Hendricks.
Okay.
Right. Okay. Your first assignment was to download it. And I looked on Canvas a few hours ago, and I saw that most of you have submitted it. A few of you had not. It was due at the beginning of this class, so that was 13 minutes ago. It was due 13 minutes ago. If you haven't yet done it, you can still turn it in, but it'll be late. And when you read the disclosure, you hopefully noticed that one of the class rules is that you're only allowed 2 late assignments. Now, I recognize that there are lots of things that arise in people's lives that cause you to miss an assignment. That's okay, I understand that. I will give credit, I'll give full credit even, for 2 late assignments, but only 2. So if you didn't turn in this disclosure statement by 2:10 today, it will count as one of your late assignments, and then you've already used up one of your 2 late assignments, so not cool. And then the other assignment was, of course, to download and read the short story that we talked briefly about last time. We're going to talk in more detail about it today. And again, when I checked Canvas earlier today, I saw that most of you have submitted the answers to the questions that I asked about. But again, some of you did not. So now that was a couple hours ago, so hopefully you've done it by now. Some of you may have used up both of your late assignments already just today, but hopefully you didn't. Before I launch into the class, do any of you have any questions about anything? You can either type them into the chat box or you can turn on your mic and you can speak them.
So for the assignment that we're about to go over, we just talked about it. For me and Valerie, can we still turn it in, or does it still count as a late assignment?
Yeah, it won't count as late for you guys because you guys weren't here last time. Yeah, so
yeah, thank you.
So don't worry, it won't count as late for you.
Thanks.
All right. Yeah, no problem. Okay, let's get started. So what I'm going to do now is I'm going to share my screen. Not that one, this one. Okay. This is my Canvas screen. Yours should look similar. You're not going to have this stuff over on the right side. Let's go into this class. So the one with the space shuttle here, that's yours. I have 2 engineering classes, as we talked about last time. The engineering principles is for the 10th, 11th, and 12th graders. Engineering technologies is for 9th graders. So this one's yours. When you click on that one, it will take you to a page that will look like this. And these icons down at the bottom, we talked about those last time. The assignments page is the one that's going to be the most important for you. And so you're not going to have some of the stuff that I have here. All right, so the first assignment was that one right there. Read the disclosure statement, confirm that you've done that. And hopefully now you guys have all done that, so we don't need to talk about that. Let's go back to the previous page. All right. Okay, so the other assignment that was due last night is this one. What's the difference between science and between engineering and science? So a lot of people don't understand that. They think, well, they both deal with math and physics. They both deal with solving problems. And so this story that I had you guys read, the one that's Superiority by a guy named Arthur C. Clarke, uh, it is I think it's a great story. Um, I had never heard of it until I saw something on some website once that said that students who attended MIT, the Massachusetts Institute of Technology, one of the things that all incoming freshmen for MIT were required to do was to read this story. Do you guys know about MIT? That's a school that you should all know, especially if you're even a little bit interested in engineering. You should
Yeah.
know about MIT. All right, so I see in the chat box here, somebody just typed something, but it's not, when I share my screen, it sometimes messes up the chat box. Okay, all right, so some people are saying yes, sir. So Max or Justin, tell us a little bit about what is MIT? What is Massachusetts Institute of Technology? When you guys said yes into the chat box, I assumed it meant yes, you know what it is.
It's a really good school.
Okay, can't argue with that. Yeah, so it's a really good school that emphasizes engineering. So if you're an engineer, to go to MIT is like, wow, one of the primo schools. In fact, many people say it's the primo school, although there are people at Caltech and UC Berkeley and the University of Utah who might disagree with that, but it's a really cool school. So I don't know if they still do it now, but I know for a while, they required that all the incoming freshmen had to read this story. And I'd never seen this story, so I thought, well, that's interesting. I better get a copy of this story and read it. And once I read it, I could clearly understand why it would be required reading. And so I've made it be required reading for my class as well. So Ibrahim is asking, is it hard to get into MIT? And the answer to that is most definitely yes. But we have had many of our AIMS students get into MIT. AIMS is an excellent preparation for this. We do stuff at AIMS that will give you a huge step up, and that will really help make it a lot easier for you to get at MIT or Caltech or the University of Utah or any of the other schools. The more you know, yes, right. Okay, so let me get back to here. All right, so I'm trusting that you guys all did that. And now I need you to report back. So if your last name starts with the letters A through H, your assignment was to talk about the first of the three inventions that they talked about in that story. And so what I'd like you to do is right now, I'd like you to tell us. So somebody who's in that first group there, can you turn on your microphone? And if you want, if you're willing to also turn on your video, that'd be good too. And tell us. In fact, let me stop the sharing here. Okay. So somebody tell me, what is the sphere of annihilation?
Oh, hi. Can you hear me?
Yeah, I can hear you.
Oh, okay. So yeah. So I got the sphere of annihilation. So what it was literally a sphere of annihilation. You would launch it, right? Okay. So and then it would basically the exact wording in the story was disintegrate. So it'd be is it disintegrate or no?
Yeah, that's right.
Yeah. So disintegrate matter over like a radius of several hundred meters. So basically, you were there, and then if they activated it, you just basically disappeared. You'd be like atoms. So it'd be very useful to like destroy ships and stuff like that because there's a very huge radius.
Okay, so it's a super bomb. Okay,
Yeah.
so it sounds like a pretty cool invention. But when they went to use it, it didn't work out very well for them. Why not?
Well, one thing was that it they found out that like the radio transmissions, it activated the bomb, like it was supposed to, but it activated it. So like it said that one of the training ships got destroyed because of that. So, and then another thing they were talking about was that the spheres didn't fit on the torpedoes because they were too small.
And why is that a problem? I mean, sounds to me like there's an easy workaround, just build bigger torpedoes, right? So why is that why was that a huge problem for them?
It was because like right when you build the sphere, it would blow up, right?
Well, you already talked about that one, but the torpedo thing, why was it a problem? So the sphere was too big to fit in the torpedoes that they had.
Mm-hmm.
So an easy workaround to that is just make bigger torpedoes. But why did that turn out to be a big problem for them?
Does it have to do something with their own ships to be destroyed, or
Not
like
so much. Anybody
No.
else want to kick in? You guys all read the story. Somebody else speak up. Why was the torpedo issue a bigger problem than they anticipated it was going to be?
Well, it took a lot of time to make new torpedoes for them to fit. And
Exactly.
Then,
It was the time. Okay. And so this is the first thing about the difference between engineering and science that I need you to all understand. The sphere of annihilation, if you look at it from a scientific point of view, it's an amazing scientific breakthrough. It's like when they invented the nuclear bomb or the atomic bomb. It's a tremendous scientific achievement. Okay, but the sphere of annihilation had some engineering issues that proved to be a problem. It was too big to fit in the torpedoes that they had. And so they had to build more torpedoes. They had to go back to the drawing board and redesign bigger torpedoes. And so in their ships, they had to have bigger torpedo launchers. And so they had to completely revamp their entire series of ships. Now, hopefully you guys remember that at the beginning of the story, we had these two sides. We had the side that I'm going to call the good guys, although whether they were actually good or not is certainly questionable. I'm going to call them the good guys. And then there's the enemy. At the beginning of the story, the good guys looked like they were clearly going to win. They had more ships, more torpedoes, more of everything. And so they were clearly going to win this war. If they would have just stuck it out, they would have won it. But they wanted to shorten the war. They wanted to do it more efficiently. And that's an admirable sense because as the war goes on, people die, people on your side as the other side. So they thought that this new invention might make it easier to win the war and fewer people would die. That's an admirable thought, right? And so they came up with this thing that was a tremendous scientific breakthrough. But it ran into some problems that they had to design new torpedoes, new torpedo launchers, and it took time for them to do that. So they had to stop building the regular ships and the regular torpedoes, and they switched all of their production over to making these new ships, new torpedoes. And while they were doing that, the enemy was building more and more ships and more torpedoes. So at the beginning of the story, they had more ships, more torpedoes. They could have won. But because they took all their time in these new ones, the enemy was building more ships, more torpedoes. And so by the time they finally got the sphere of annihilation working right, they went back to battle and they found out, surprise, surprise, the enemy now outnumbers them. They now have the disadvantage. So scientists usually don't have to work under a time deadline. Scientists can usually take as long as it takes to make their invention. And if it takes a little longer than they hoped, well, no big deal. But if you're an engineer, it's a big deal. Now, as I mentioned last time, I have not been a teacher my whole career. I'm actually retired. Okay, I'm a retired engineer. I used to work in Silicon Valley making computer chips and things. And boy, did we ever have to worry about time. When we sat down to develop some new product, we were given a time frame. This product had to be complete by this deadline, because if it wasn't complete by that deadline, then the people who were going to buy it would go and do something else. So if it was crucial, it's vital that we had to meet the deadline, which is something scientists just quite often don't have to worry about. All right, so I think this first one does a really good job of illustrating that kind of difference between science and engineering. Now, how about the next group, the people who had the battle analyzer? Somebody speak up and tell us, what is this battle analyzer and why did it not work out as well as they thought it would? Come on. So Preston, Mahanri, Moana, or Manoa, sorry. Speak up, guys.
Hi. So I kind of rushed the story, but wasn't it like it was supposed to like replace all the guys in the organization that were thinking. So it was basically, I don't know, like it was like a super brain kind of.
Okay. All right. It was a super brain, and it was important because the sphere of annihilation took so darn long to develop that when they went back into battle with it, they found out that the enemy now had more ships than they did. They didn't at the beginning of the story, but now they did. And so then they came up with this incredible invention, a super brain, that allowed them to, it would control the ships and it would allow them to use their ships more effectively. So even though they were outnumbered, they could still win the battles. Okay, so wow, that sounds like a great invention. So Mahanri, why did it not work out as well as they thought it would?
It took a really long time to get it installed, and also it was super complex, and it needed, I don't remember. What was it?
A whole lot.
It needed 500 technicians to operate it. So when they were training everyone, 40% of them had a mental breakdown. So 60% of them had a mental breakdown. So only 40% were actually qualified to help and operate it.
Okay.
And it also like exposed kind of like the heart of their operation, so they could just go and attack that part, and then everything's over.
Okay. All right. I like that. All right. So the battle analyzer worked wonderfully, except it was such a complicated machine. It took like 500 people just to maintain it. And training these people was really hard because it was so hard to maintain that the majority of the people that they brought into the training school didn't pass. And so so again, we have a time factor. But even more than the time factor, there were so many people needed to maintain it that they couldn't fit on military ships. So they had to bring in like basically a cruise ship, a space-going cruise ship. It wasn't intended for military use. And so when they would go into battle with their fleet, in addition to all of the fighting ships, here's this great big cruise ship in the middle of the fleet there. And so when the enemy saw that, they said, what the heck is a cruise ship doing there? But the cruise ship was necessary because it housed all the people that maintained the battle analyzer. Okay. And then in one of the battles, the cruise ship just accidentally hit a mine and the cruise ship was destroyed. And then the people that I'm going to call the good guys, once the cruise ship holding all the maintenance people, once that was destroyed, they immediately withdrew because without the battle analyzer, they lose their advantage. And the enemy saw that. And so the enemy was really perplexed as to why is there even a cruise ship here? That doesn't make sense. And then they noticed that as soon as the cruise ship was disabled, the fleet withdrew. So the enemy figured out that this cruise ship is obviously really important. And so in the next couple battles, what the enemy did was they focused all of their ships on attacking the cruise ship. And when they did that, then the people withdrew. So even though the enemy didn't really understand the significance of the cruise ship, they figured out that it was important. And so it turned out they were able to win the battles there, even though the good guys had this battle analyzer. Okay, so now why is this important for our discussion today? Well, because if you're an engineer and you're designing something, you have to understand that if it's really, really complicated and if it takes a whole lot of training and a whole lot of smart people and a whole lot of time in order to maintain it, then it's probably not a very good invention. Things that you as engineers design, they have to be easy and simple to operate, easy and cheap to maintain. You as an engineer are responsible for figuring out how to do the maintenance on your equipment. So the scientists who worked on the Battle Analyzer, they thought like scientists. They didn't think like engineers. And the Battle Analyzer was a tremendous invention. I mean, it did a great job at what they intended it to do. It did allow you to win the battle even though you were outnumbered. But the maintenance issue was a big problem that the scientists didn't think about. But if you're an engineer, engineers definitely have to think about it. All right. Okay, so that's another important disadvantage or difference between science and engineering. Okay, now the last one, the exponential field. Somebody please speak up and tell us what is that and why did that not work out as well?
Oh,
as
I can do
we-
that.
Okay, good.
Okay, so the exponential field. Okay, so what it was when you turned it on, it would stretch time. So it would look like if the, how do I say it? If the enemy is this far away, right? You
Can
move
you
close
turn-
to it, but you
Can you
turn
turn up your camera so when you say this far, we can see what you mean?
Oh yeah, my bad. So it would make it seem like your ship is way farther away when in reality it's like really, really close. So like say if this is the enemy ship, this is the
The good
The
guy
ship.
ship.
good guy ship, sure. They turn it on. It looks like they're all the way out here, okay?
Oh, looks like that the Ames network is
So,
being
like
bad
what's
again.
time? So time, the universe, all the way here. And when they turn it off, it comes straight back. Yeah. Pardon? Yeah. Sorry, it's just saying my name.
You kind of locked up on us for a while there,
but-
but you're back now.
Okay. Okay. But the problem with it was that every time you did it, the universe would still get a little bit more warped or elongated. So in retrospect, it wouldn't go back to its original state. So, and then they started trying to chase other enemy ships, and every time they were trying to use it, their calculations were off, and they were wondering why. And oh yeah, is that good?
Okay, all right, I'll accept that. Okay, so yeah, what it did was when you flipped on this machine, it would stretch space around you. You guys, I trust you've seen the TV show Star Trek, or you've at least heard about Star Trek, and they have these special engines they call warp engines. And they say, they use that as a way to measure speed. They say, we're going a warp 1 or we're going a warp 7 or whatever. The idea there is pretty similar. It somehow distorts the space, which allows you to travel through it differently than you would through normal space. So this one's kind of the same idea. It's almost as if it makes you invisible. So you can think of it that way if you want. So you flip on this switch and it stretches space. And then you go and you park yourself right next to the bad guy, but they think that you're really far away, which maybe you really are. And then when you flip the switch off, it's like you magically appear right next to the bad guy, and the bad guy wasn't expecting it. They didn't see you coming, but you were expecting it. So you've got your guns all pointed and all loaded and all ready to go. And as soon as you appear next to them, you blast them before they have a chance to react. All right. And then if they're other friendly, if their friends are around, their friends see you, and so they come over to try and attack you. But then you just flip on the switch again, and off you can go. So, as a scientific breakthrough, this is an amazing invention. The physics involved here in warping space is tremendous science. But the engineering problems were substantial. So as Keeler mentioned, when they turned on the switch and it warped space, okay, then when they flipped the switch off, it would come back, but not exactly like it was before. So think of it like you've got a yardstick. And so you flip on the field and this yardstick gets stretched. You flip off the field and the yardstick bounces back. But when it comes back, it's not exactly 1 yard anymore. Now it's 0.999 yards, which is really close to 1 yard, right? So when they did this, the first couple times they used the field, they didn't notice any problem because everything seemed to come back to the same way that it was, but it was just a little tiny bit different. And every time they used the field, these little differences would accumulate. So after using the field a couple times, their entire ship was not exactly the same size as it had been. So let's say that they need to replace a part. There's, maybe a motor, things wear out, that happens, right? So you go back into the repair yard and you pull out the old motor and you want to put in the new motor. The new motor doesn't fit because the ship has been stretched and then returned so many times. The holes are just a slightly different size. And so you go to take this new motor and you try to put it in there, the new motor doesn't fit. Or even worse, the communications equipment. In order for the communications equipment to work right, everything has to be calibrated just perfectly. And when all the arrays and the sensors and the antennas and things been stretched and returned so many times, the calibration goes a little bit off. So when you're trying to communicate with another ship, the frequency isn't exactly the right frequency anymore, so they can't hear you anymore. So these are engineering issues that came to bite them. And by the way, this effect when you stretch something and then bring it back and it doesn't come back exactly where it was before, there's a word for that because that's a real phenomenon that happens in the real world. It's called hysteresis. Okay, hysteresis, Hysteresis. Hysteresis. That's something you're going to need to know about. All right. So, what's that? Can you type it in? Yeah, thanks. I'll type it in.
Could you type it in the chat? I just want to know what it's called.
Okay. Hysteresis. All right. That's when you stretch something like a spring, right? You guys have all played with springs. You stretch a spring. If you only stretch it a little bit and then you let go, it bounces back to where it looks like it's exactly the same as it was before. If you were to stretch it a lot and then you let it go, then it won't come back exactly the way it was before. So that's called hysteresis. And that's the thing that engineers need to deal with. And so the scientists who developed this new exponential field, well, they were scientists. They don't have to worry about little details like that. Just the invention of the hysteresis, of the invention of the exponential field, that in and of itself is a tremendous breakthrough. But these little details, they'll come and bite you. You've heard the expression, the devil's in the details. Well, this is a good example. And so engineers need to worry about the details. And it's those darn details that kill them. So in the end, the team that I'm going to call the good guys, they ended up losing the war. Okay, even though at the beginning of the story, they were clearly in a position to win. They had more ships, more torpedoes. They were clearly going to win this war, but they ended up losing it because their scientists, although they were great scientists, they were lousy engineers. Okay, so I hope this story just does a reasonable job of letting you know that's one way to think about the difference between science and engineering. Engineers have to worry about all these little details. Okay, are there any questions before I move on to the new stuff for today? I'm going to take that silence to mean no. All right, okay. Let me go back into, so I'm in my Canvas account now. Let's go back into the place where the assignments are all listed. All right. So this video here, What is Engineering? That's the video that we watched last time. So the two of you who are new this year, today. I recommend you click on this and go in and watch this little video here. I'm not going to play it for you now, but I think it's a nice little video that kind of lets you know what engineering is. The difference in engineering and science, that's the one we just talked about. So here is the assignment for today. Cool inventions and the engineering fields that were involved in developing them. Let's click on it and see what it says here. All right, so your assignment is to search YouTube, or it doesn't have to be YouTube. I could just say search the internet, but I like YouTube because it has lots of videos. So find an invention that you think is cool, send me a link to that video, or if you can't find a video, send me a link to either the article or the photograph or something, so I can post it here so other people can see it. But in addition to sending me the link there, I want you to send me, or I want you to include a short written description telling me how the thing works. And now here's the important part, which of the various engineering fields were involved in developing it. All right, so I'm sure that some of you already know that there are different areas of specialization within physics or within engineering. So you've heard of mechanical engineering, electrical engineering, chemical engineering, all those types of things. So when you write up your description of your invention, I want you to tell me which of the various engineering fields were involved in developing it. So hopefully you'll understand better what I mean after you watch my video. This video that you see right here, this is what I would submit if I was a student and I had been given this assignment. This is a jetpack. Now, jetpacks have been around for a long time, but they never really worked very well. But recently, this company in England here, they have now refined the jetpack. They've got it to where it works pretty well, and it's really cool. So let's watch the video and then let's talk about it. Let me start the video and then I'll make it be full screen so it's easier to see. Now I've got the sound turned off right now because the music is so darn loud that if I was playing the music right now, you guys wouldn't be able to hear me talk. Is that cool or what? Okay, let me go turn the music back off again. Uh-oh, what happened to my thing? There we go. Okay, I see a lot of people are typing something into the chat box, but I can't see what it is. Oh, okay. Yeah, because when I share stuff, the chat box goes away. All right, yeah, I should have warned you about this. Yes, it is really laggy. And this is a Zoom problem that I don't know a workaround for. So when I play a video, yeah, it's really, really laggy and choppy, or whatever you want to say. So I apologize for that, but let's watch anyway. I mean, it's not very long. It's just like maybe 2 or 3 minutes at all. So let me go back and I'm going to replay it. So even though it's choppy, you can still hopefully get an idea from it. So let's go back and let's try again. And here it goes. All right, so now this time there's going to be 3 of them. Okay, now look, you see on their hands, they've got jets on their hands. Is that cool? I love this. Oh, I want one of these. Can you see, if you were a Navy or military at all, this could be a very good weapon to use. You know, if there's some terrorist ship or some enemy ship and you need to get on board it, this would be a great way to get on board. It's almost over here.
Yeah, it would be a good
Okay.
to get on board.
Now I realize that was choppy. Tell you what, I'm going to find a frame here that hopefully shows it better.
I think if you download a video, runs smoothly. But
Oh yeah, I know it does. But this is probably good. Let me play a little bit more. Okay, there. I'm going to stop it right there. Okay. All right. So let's talk about this. All right. Let me turn on the annotation. All right. So if you look at how this works, you can see that on his hand, he has these little jet engines, and on his other hand here, he has these jet engines. But also on his back, there's a jet engine there as well. All right, so what's happening is this engine on his back is shooting out air, and the engines on his hands are shooting out air as well. And so by moving his hands around, that's why he can control what direction he goes. But most of his weight is supported by the engine on his back here. And so this is a new way of doing jetpacks. It's different from what people had done before. All right, so if I were to submit this as my the video that I think is cool, in addition to submitting this video, I also need to write up a little description of what engineering fields were involved in developing this. Okay, so before we answer that for my video, let's go through and let's talk about all of the different engineering fields. I know that some of you already know. So somebody speak up and tell me one of the engineering fields, and only tell me one. I want to spread this out.
Computer engineer.
Computer engineer, very good. So tell me, what do computer engineers do?
Don't they work with like a lot of coding to code things like artificial intelligence?
Okay, very nice. All right. Now, up until a couple of years ago, computer engineering and software engineering were kind of the same thing. And so what you said would definitely be true. In recent years, most universities have separated them out. So if you were to ask somebody at a university what a computer engineer does, they would tell you that a computer engineer specializes in making the computer hardware. They specialize in designing the chips and figuring out how to route everything. They focus in on the hardware. And so what you just described was the people who come up with the code, clever ways of coding computers. That used to be part of computer engineering, but nowadays they switch it out, at least in most schools. And so they have a separate department that's called software engineering. So nowadays, at least, software engineering and computer engineering are two separate fields. The computer engineer deals with designing the computer, the hardware, whereas the software engineer does the coding. So those are two important fields. So thank you for that, Valerie. Somebody else now. Tell us about another engineering field that you know about.
Agricultural.
Agricultural. Tell us about that.
So don't agricultural engineers, don't they work on products and like tools to help make like farming and stuff like easier, like better in a way? No?
Yeah,
Yeah.
very good. Yes, there are definitely engineers who focus exclusively on farming and figuring out ways to improve farm tools, farm methods. Yeah, so agricultural engineering, very good one. And that's one that most people don't mention, so I'm glad you got that one. Somebody else.
Medical engineering.
Medical engineering, also quite often called bioengineering. Okay, so biomedical engineering. Tell us about biomedical engineering.
Well, I believe it's like I don't know the exact word for it, but some of the products it's like for capillaries in the bloodstream, and it like unclots them or something. I saw a video on it.
All right, very good. So some people get blood clots, and so bioengineers, they come up with devices that you can insert like let's say you've got a blood clot that's in your heart, but open heart surgery is a really big deal and really dangerous. And so bioengineers have figured out ways that you can insert something in your arm, a very skinny little tube-like thing, and then they can run it up your artery and inside you until it gets to where the clog is, and then they can break up the clog. Yeah, so that is definitely an example of a biomedical engineer or bioengineer. They have different names, right? Artificial arms, artificial hearts, implants that you put into your brain that allows you to control your artificial arm. All of this stuff, basically anything that interacts with the human body, that would be a bioengineering thing. Yeah, somebody else.
Civil engineering.
Civil engineering, tell us about that.
It's basically building like things for people in metropolitan areas, I guess. Like, I guess elevators would be a kind of civil engineering thing, or like building bridges or things to make it easier to do daily tasks, I guess.
Okay, all right, bridges. Bridges are a perfect example. Most people, when you ask them about civil engineers, they say bridges. And bridges are certainly an important thing. Basically, anything that doesn't move, anything in our society, like a bridge or a building or a road, that makes our civilization work, but not stuff that moves. The stuff that moves is a different category. So elevators by themselves would not be a civil engineering thing, but the elevator shaft, or better yet, the building that it goes in, okay, that is definitely a civil engineering thing. Bridges, buildings, roads, sewer systems, that's something that a lot of people don't think of, but that's actually a civil engineering thing too. So yeah, civil engineers, very good. Elliot, yeah, go ahead.
Propulsion engineer.
Say that again.
Propulsion engineering.
Propulsion, wow, that's one that nobody's mentioned before. Tell me more about that.
A propulsion engineer helps build propulsion systems for aircraft or spacecraft, or
Okay,
even missiles. Most of the
Okay.
time.
all right, very good. Now,
Like, sorry,
Go
go
ahead.
ahead. No, you go.
okay, so at most schools, this field that Elliot called propulsion engineering, usually that's a subset of a larger field called aeronautical engineering. But there are sometimes people who do specialize in propulsion engineering. But in most schools, they've got this field that is called aeronautical engineering. So that includes anything that flies through the air. And that would include the propulsion that's necessary to make it fly. So airplanes, spaceships, missiles, helicopters, all that would fall under the broad category of aeronautical engineering. Okay. Somebody else.
Marine engineering.
Marine engineering, tell me about that.
Like boats, ships, etc., and equipment used at sea.
Okay. So anything that's used at sea. So, ships and things, but also not just that, but any equipment that you put out in the sea, any sensors or maybe generators. There are people who are using wave energy to develop electricity. So anything that goes in the sea and interacts with the sea, marine engineers get involved in that. Great, you guys are coming up with some good ones that usually when I ask these questions, people don't mention these. Okay, how about somebody else?
Automobile engineering.
Automobile engineering, okay. Tell us more about that.
They work with the vehicle design and
Okay,
how they,
Alright.
what's it called? How they develop the vehicle and the production, and I think they test it as well.
okay, great. Now, at most schools, auto engineering is not a separate branch by itself. Auto engineering is a subset of a larger field of engineering called mechanical engineering. So mechanics is a word that means things that move. So when you guys take my physics class, which I hope you will very soon, the first part of the year, we spend the whole year talking about something called mechanics, which means the study of motion. So a mechanical engineer is somebody who deals with things that move. So automobiles, clocks, motors, robots, anything that moves, that is that falls under the category of mechanical engineering. And so automobiles is certainly part of that. There are sometimes people who specialize only in automobiles, but more generally, what would happen is that they would major in mechanical engineering and just specialize in auto engineering. So thank you, that's a good one. How about a few more? So Elliot's saying there are people who design elevators, and I agree with that. But usually those people would be called mechanical engineers. They just specialize in elevator engineers. Justin, what you got?
There's electrical engineering.
Ah, okay, very good. Tell me about that.
Electrical engineering is like kind of broad. They deal with a lot of like a wide range of stuff using electricity, like from big to small, I guess.
Okay. All right, so anything that involves electricity would fall under the category of an electrical engineer. So a little bit earlier, we were talking about people who design the hardware for computers. So computers use electricity. Therefore, if you want to design a computer, you're probably going to have a team. In fact, you're certainly going to have a team of people. And one or more of the people on your team will be electrical engineers, and their area of expertise is how to carry the electrical signals from one part of the computer to the other part of the computer, how to do that reliably and have the right voltages and everything. And then somebody else on your team would be a computer engineer who figures out what are the things you want to connect. We're going to talk a lot more about this in a few minutes, but basically you're almost always going to be working on a team where you have people from different disciplines work together. So yeah, electrical engineering. Valerie, you got a suggestion? The reason I picked on you, Valerie, is because your name came up here, so it looked like you unmuted your microphone. All right, Max, go ahead.
Does somebody already say environmental engineering?
Ah, nobody said that one yet. That's a good one. Tell us about that.
It has to do with pollution and environmental quality.
Okay. All right. So there are lots of engineers out there who are trying to figure out ways to clean up our environment, which we have really messed up big time. My generation and all of us old people have really screwed up the world for you young people, and I apologize on behalf of everybody in my generation. Global warming is a huge problem. The plastics that are out in the ocean. I do a lot of sailing. We're going to talk more about that, but sailing is like one of my most favorite things to do out on the ocean. I spend all summer long out there. And here I am sailing around in the middle of the ocean. I mean, literally, 1,000 miles away from land. And I look outside and there's a plastic bottle floating there in the middle of the ocean. And when you come to some island, again, an island in the middle of the ocean, right? And you go out, you anchor and you go ashore and you think you're going to walk along this pristine, beautiful beach, and there's plastic everywhere. Where did it come from? It's in the middle of the ocean, and yet it's completely covered with plastic. It's a huge problem. So environmental engineers, they are working on ways to try and deal with that. Okay, let's do two more and then we're going to stop. We could do a lot more than two, but let's just do two more.
Did anyone say chemical engineering?
Nobody said that yet. That
I
would be a
was
good one.
just about to say that.
Okay, tell us about it.
Well, chemical engineering is chemicals, making new chemicals. So it uses a lot of the periodic table, I believe.
Mm-hmm.
And I guess I'm reading about it right now. How do I say it? They make cleaner technologies. So, cleaner technologies, calculating environmental impact, study the fate of chemicals in the environment. So, could chemical kind of be related to environmental? Is that like mostly what they work on?
Yes. A lot of times environmental engineers focus in on the chemistry of it, but sometimes they focus in on the mechanical aspect of it as well. Yeah, let's talk more about chemical engineering. So anything that involves chemicals. Like for instance, gasoline. The gasoline that you put in your car, it didn't start out like gasoline. When they first take oil out of the ground, which is where gasoline comes from, doesn't look anything like the gas you put in your car. It's black, it's thick, it's gooey. And so somebody has to put that through a whole bunch of chemical processes. They heat it up and they put it through special things that can separate the thinner oils from the thicker oils. There's a whole lot of chemical processes that go on. And so somebody who understands chemistry and who also understands engineering together has to optimize these processes. Food, a lot of the food that you eat is cooked and the ingredients are processed through chemical reactions. And so somebody has to design the processes for doing that. Makeup, the makeup you put on your face, that's a combination of chemicals, and chemical engineers get involved in that. Okay, so let's cut it off here because I don't want to go on too long with this. I think we have a good idea now of some of the different fields of engineering. We definitely haven't hit them all, not by any means. So let's go back to my Canvas page and let me make this smaller again. All right. If you look up above the video that I put on Canvas, you'll see I've got a link here. Let's click on that link. And you'll see it takes you to a page where it talks about the different types of engineerings. And even this list is not totally complete, but it's a pretty good list. And many of the ones that we've talked about are on here, but you'll see that some of them, like manufacturing engineering, we haven't talked about that one. And let's see, this one here that they call ceramic engineering, which is also materials engineering. We haven't talked about that one either. So there's a bunch on here that we have not yet talked about. So I want you guys to read this and get an idea for the different fields of engineering. And then when you did that, now I want you to go back and let's look at my, my video again. So if I were to submit this video, if I was a student and I submit this video as my, my submission for homework, just submitting the video alone is not good enough. I need to look at my invention and I need to ask myself, which of the various fields of engineering were involved in this? All right, so let's go back. So remember how this works. We've got all these out of each of his hands. We got these jet exhausts shooting out there. All right, so look at my engineering invention here, and let's have you guys list which of the various fields of engineering had to have been involved in developing this. What do you guys think?
Definitely chemical engineering because of the fire and using the.
Yeah, I definitely agree. So the way jet engines work is they take fuel, kind of like gasoline. Generally they use a special kind of fuel called aviation fuel, but it's like gasoline. Okay, so they're burning this fuel, and in order for it to work right, they have to mix the fuel and the oxygen. They have to mix those together in the right ratio, and they have to design a little chamber where the combustion can occur, and then that chamber has to be designed just right so it's efficient. So absolutely yes, chemical engineering, huge part of this, but it's not the only part. What other parts are there?
Electrical
engineering, yes, because in order to control everything, okay, yeah, I'll get to that one at a time here. So in order to control everything, you can bet they've got sensors that are looking at all of the different outputs and adjusting things based on what it sees. And so you bet there's going to be a microprocessor or microcontroller in here somewhere. So there's going to be chemical engineering. Now I heard somebody just said mechanical engineering. So yes, inside these jet engines, there are blades that spin really fast. And so yeah, there's definitely going to be mechanical engineering involved here. Anybody else?
Aeronautical.
Aeronautical, yeah. I mean, what is this thing? It's a flying machine, right? And so the propulsion and all of the things that aeronautical engineers need to get involved in, yeah, big time. aeronautical engineering. Any others?
Could petroleum engineering be part of it?
Yeah, definitely, because anything that uses fuel, you're definitely going to have petroleum engineers, and you need to make sure it's the right kind of fuel. Different fuels burn at different rates. So, like I said, most aeronautical things, airplanes and things, they don't use regular fuel like the gasoline that goes in your car. It doesn't burn at the right temperature, right? So you need a different kind of oil that burns at a different temperature and different rate. So petroleum engineers for sure are going to be involved in this.
Probably software for the computer inside of it, and also computer.
Yeah, absolutely.
engineering. Yeah.
You can bet that there's at least a microcomputer somewhere in here, because these jet engines are really hard to maintain. Everything has to be just right. The fuel flow rate has to be just right. The oxygen has to be just right. And so the pilot, he can't spend time, or she can't spend time focusing on all those things. She's going to have a little microcomputer built into her jetpack. And so it's monitoring all these little things so that the pilot doesn't have to think about it. Okay, let's cut it off here. We could go on, but let's cut it off here. Let me stop sharing. And let me see. I see, geotechnical engineering, interesting. I wouldn't have thought of that. Okay, so you guys understand now what I want you to do. So there's two parts to it. One is I need you to find some interesting invention and send me a link to it. I prefer video links, but if you can't find a video link, if you can just send me a photograph or an article or whatever, I'd be okay with that, but I prefer video. But that's only one part of it. The other part is that I need you to make a list, and don't just list them. Don't just say chemical engineering, electrical engineering, mechanical engineering. Tell me, if you say electrical engineering, give me a sentence or two telling me what specifically do the electrical engineers do. And chemical engineering, don't just say chemical engineering. Include a sentence or two telling me what specifically did the chemical engineers need to do. All right, go ahead.
Sorry, really quick. Can we send a project made by one person if it's still complex? Okay.
Yeah, I'd be okay with that. Now, I would be surprised because most of the cool things that are invented in the world now are so complex that usually one person can't be an expert in all the different things that that are necessary. But hey, if you can find something like that, okay, I'm certainly willing to accept it. Okay, now, go ahead.
How do you want us to send the video link to you? Do you want email, or is there a text box that you want us to paste it into?
It's in Canvas. So
Okay.
if you go into Canvas, all right, so you're going to have an assignment that's going to look just like, or going to look very much like this. It won't be exactly the same. The teacher version of Canvas is slightly different than the student version. On the version that you have, when you go to this page, there's going to be a box there. And the box is going to say submit, okay? When you click that submit box, you're going to see two different fields are going to open up. One field is going to be the field where you can click the link to your video. And then the other field is going to be a text box. And that's where you're going to write the description of the different fields of engineering that are involved and the description of it. So it'll all be done through Canvas.
Okay, thanks.
Any other questions? Okay, now remember, guys, I take roll at the beginning of class, and I also take roll at the end of class. So before you guys leave the Zoom meeting here, I need you to type into the text box. I need you to say bye or something to that effect. If you don't do it, then you won't get credit for the assignment. And so after you've done that, then you can go ahead and log off, and I will see you. You guys know we meet on Monday, right? Tomorrow's an A day. Even though we don't meet, it counts as an A day. So we're going to meet again as a class on Monday.
I thought Monday was Labor Day.
No, that's next week. That's the week after.
Oh, okay.
Yeah. All right. So I will see you guys later.
All right. Have a good day.
If anybody has any questions,
Thank you so
if
much,
you don't,
Mr. Hendricks.
Hey, my pleasure. If
Yeah.
you have any questions, if there's anything you didn't fully understand, stick around and we can talk one-on-one.
Thank you.
Hey, you're welcome. My pleasure.
Okay.
Yeah.
Thank you.
Thanks. Have a good day.
Hendricks.
Thank you too. All right. Apparently there's no questions. I will go ahead and stop the recording.